Whether a data point is an outlier or not, first you determine the first and third quartiles, then you compute the interquartile range. So how do we compute the interquartile range?
Q1 minus Q, or Q3 minus Q1.
Q3 minus Q1. Okay. Then we're going to determine the fences. So the fences are the cutoff points for outliers. Everything inside of the fence is not an outlier. Everything outside of the fence is an outlier. Okay? So the lower fence is going to be Q1 minus 1.5 times the interquartile range. So you first, and you're going to want to put these on your card, okay? You're going to first calculate the Q1 and Q3, then calculate your interquartile range, then Q1 minus 1.5 times your interquartile range is your lower fence, and Q3 plus 1.5 times your interquartile range is going to be your upper fence. If your data value is less than your lower fence or greater than your upper fence, it's going to be an outlier. Any questions on that? Okay. Okay, so this is the same data that we were looking at, the cars driving in the school zone. Okay, so here are our data points. Okay, we found Q1 and Q3 to be 28 and 38. So the interquartile range is Q3 minus Q1, which is 38 minus 28. So that's 10. Okay, so our lower fence is Q1 minus 1.5 times the interquartile range. So Q1 is 28 minus 1.5 times the interquartile range is 10. So 1.5 times 10 is going to be 15. 28 minus 15 is 13. So the lower fence is 13 miles per hour. The upper fence, you take the Q3 and you add 1.5 times the interquartile range, which is 10. So 1.5 times 10 is 15, plus 38 gives me 53. So any values that are less than 13 or higher than 53 would be considered outliers. So that one that I added in, 100, that's definitely an outlier, right? But the other values that I had, if you look at all these values, are any of them less than 13 or higher than 53? No. So those would not be considered outliers. Okay, any questions on that?